Hello everyone. In this unit, I am going to talk about BJT biasing and amplifiers. This comes under Unit 2 of Analog Electronics Circuits. So what are the contents we are going to cover in this video? First one is transistor can be used as a switch. Transistor can be used as an amplifier. What's the need of biasing, operating point, and the multiple choice questions. After learning all the contents, we are going to solve on multiple choice questions, which helps us to understand the topics in a better way. So let's begin. So before starting the operating modes of transistor, just we'll recap what is a transistor. In the previous year, in the first year, all of you have studied what is transistor, how it is operated, the construction of a transistor, how the current flows, what are the different methods of connecting a transistor. Just in a 5 minutes, we will do the recap and then we'll go with that, how the transistor can be used as a switch as well as amplifier. So all of you know the transistor is a 3-terminal, 3-layer device. The terminals are base, emitter and collector. So with these 3 terminals, we can connect in 3 ways. So always in order to work a transistor as a switch or it may be an amplifier, we need 2 circuits. One is an input circuit and one is an output circuit. So in order to connect input and output, we need 4 terminals, but we are using a 3 terminals to connect it. So one terminal is made common. Either it may be a base or it may be a collector or it may be an emitter. So when you make base common, it's called as a common base. So if you make an emitter common, it's called as a common emitter. And if you make a collector terminal common to both input and output, it's called as a common collector connection. But the CE mode is the most commonly used method of connecting the transistor. That is, emitter is made common to both input and output because it has an highest amount of current amplification. That's why always they go for a common emitter mode of operation. So when you connect a transistor with the emitter common, the input circuit will be base emitter and output circuit will be collector base. Okay, so in this unit, we are going to use the CE mode of NPN transistor for understanding purpose of switch and amplifiers. So when you connect a transistor in a CE mode with base emitter as an input circuit and collector base as an output circuit, it can be operated in 3 modes. What are those modes? The first one is an active mode. So when you want to operate a transistor as an amplifier, it should be operated in an active mode. So let's know what's an active mode. So in active mode, the 2 junctions, that is input junction and output junctions, are biased in a different way. That is, input junction is emitter base, it is forward bias, whereas the output junction is collector base, it is reverse bias. So in this mode, the current flows between emitter and collector, and the amount of current flow is proportional to the base current. That is, if the base current increases, the collector increases. The base current decreases, the collector current decreases. So in active mode, the collector current flows all the time. So always, if you want to use a transistor as an amplifier, we have to go with an active mode, or it should be operated in an active mode. The next comes an cutoff mode. So the name itself indicates cutoff means off. So in this mode, collector base junction and emitter base junctions are reverse bias. In other way, the input junction as well as the output circuit is reverse bias. So it's completely switched off and no current flows through the device, or we can say the current through the device is 0. So that mode is called as a cutoff mode. The one more mode is a saturation mode. So we are talking about CE mode, that is emitter is made common to both input as well as output. So in saturation mode, both emitter base, that is input circuit, and the collector base junction output circuit are forward bias. So current flows freely from collector to emitter, and whenever the input base voltage is high. So in this mode, the switch is, the transistor will be always on. Okay. So these are the three modes of a transistor. So whether you connect a transistor in common base, common collector or common emitter, it can be operated in three modes. One is the active mode, where always uh, the collector current depends on the base current. If base current increases, the collector current increases. If base current decreases, the collector current decreases. So in this mode, the base emitter is forward bias, whereas the output circuit is reverse bias. In cutoff mode, both input circuit and output circuit are reverse bias, whereas in saturation mode, input circuit and output circuit both are forward bias. So using these modes of operations, we are going to study how the transistor is used as a switch, as well as the transistor, how it can be used as an amplifier. So next move to the regions of operation. So as I said, I explained in the previous slide, saturation region, cutoff region and active region. So here comes an saturation region. Saturation region is, the saturation is nothing but an highest. So in this region, the maximum collector current flows, which is shown in the diagram. This is the maximum collector current. And in saturation region, both input circuit as well output circuit are forward bias. The second one is a cutoff region. So the name itself indicates off, that is no current. So in this region, the input circuit as well as the output circuit are reverse bias, no current flows. So in between this saturation region and cutoff region, here comes an active region. So active, as I said, always the collector current depends on the base current, and depending upon that, the variation of the current will be there. But when you want to understand that when you want to operate the transistor as an amplifier, it should be operated in this region, active region. And when you want to operate a transistor as a switch, it is made to switch operate between saturation and cutoff. So as I said, in saturation region, highest amount of current flows, the maximum amount of collector current flows, whereas in a cutoff region, no collector current flows. So based on this graph, we will study how the transistor can be used as a switch or as an amplifier. So to begin with, we'll first start with a switch. So before studying how the transistor works as a switch, we will know what is switch. All of you have operated in a day-to-day life. What is switch? You have already used it. So switch is nothing but it's a simple device which is used for opening or closing of a circuit in the electronic devices. Just an example, suppose you, now Deepavali you all are celebrating, you want to turn on the beautiful lights in your house. So you turn on the switch and connect the LEDs and that will start glowing. That's nothing but an on. And when you switched off it, then the current will stop flowing and the bulbs will turn off. Okay. So this is the way how you can turn on and off. The basic operation of a switch is on and off as shown in the figure. So there are different types of switches are there, push button switches there, just a turn on switches are there, knob type switches are there. Okay, so basically a transistor switch is used for opening or closing of a circuit in the electronic device. When you turn on, the electric current flows. When you turn off, the current stops. So this switch can be made using a transistor. So when we use a transistor to work as a switch, it will be operated between the two regions, and those regions are saturation region, it is on. Already I have explained in the previous slide, saturation means the maximum amount of current flows and it will be in a on condition. And cutoff means no current flows and it will be in a off state. So transistor can be made on and off by working in these two regions. One is a saturation region and one is a cutoff region. So when you maximum current flows, it will be on. When no current flows, it will be off. So this is used to work a transistor as a switch. So now let's see how whenever switch is on, how the transistor can be used as a switch. When switch is on, it will be in a saturation state. So already I have told, in saturation state, both emitter base junction, that's called as an input junction, and collector junction are forward bias. So this is the common emitter. Emitter is made common. This is the input side and this is the output side. So input circuit consists of base and emitter. So when you apply a voltage to the base, okay, so what happens? The base emitter is forward bias. Okay, this base emitter is forward bias and the base current flows. This in turn makes the collector current to flow. So the collector current flows, and what happens is the maximum collector current flows in a saturation state. So this acts as a closed switch. We have seen in a red line. So it acts as a closed circuit. The maximum collector current flows between collector and emitter. It acts as a closed switch. So the summary is the input and base are connected to VCC. That is, high is given to the base. What happens? The base emitter is forward biased. Okay. And the base collector junction is also forward biased. And transistor turns fully on and maximum collector current flows. And when maximum collector current flows, this acts as a closed switch. So when input is high, it acts as an on. Next comes an off. When we say that switch is off, it is in a cutoff state. Cutoff state is already I have told. In cutoff state, emitter base junction as well as collector base junction are reverse bias. So what are these emitter base? This is emitter and base, and this is collector and base. So this is input circuit, whereas this is an output circuit. So in switch off state, the input is low. Okay, the input and base are grounded. So when it is 0, the base emitter is reverse bias. Already you have studied when reverse bias, no current flows. So base current is 0. So the collector current will be 0. So it will be in a off state. So it as good as the switch is open. We have indicated with the red line. So in cutoff state, no current flows and it acts as an off state. So in order to work a transistor as a switch, either it should be on and otherwise it should be off. When it is on, the current flows, and when it is off, no current flows. So this is off condition. So if you take a summary of transistor as a switch, when transistor turns on, it will be in a saturation region and maximum collector current flows. So it supplies current to the load. As I said, if you turn on the switch to turn the bulb on, when you turn on, the collector current flows and the bulb will turn on. When transistor turns off, it will be in a cutoff region. Cutoff means no current flows. So the bulb will turn off. So when using the transistor as a switch, a small base current controls a much larger collector load current. So when the base current flows, the collector current flows. So transistor is a current control device. The base current controls the collector current. And transistor switches can be used to switch and control lamps. As I said, the best example is LED lamps glowing, relays, or even motors. All of you have used a pumps or a motors to turn on your water tank pump to lift the water. So when you turn on and off, we can use the transistor switches for that. Even a relays are again one type of on and off control devices. There also we use a transistor. So a summary, if you summarize the points, when the transistor is on, it operates in a saturation region, maximum collector current flows. When the transistor is off, it is in cutoff region and no current flows. So in general, when we use a transistor as a switch, a small base current controls a collector current, load current. So load is nothing but a You can connect a bulb, you can connect any motor, that is nothing but a load. So a base current controls the collector current, which in turn controls the load current. So when we use a transistor as a switch, it is operated between saturation region, that is on, and cutoff regions, either saturation or cutoff, on and off. In this way, the transistor works as a switch. Next, the one more important application of a transistor is an amplifier. So in a day-to-day life, or you have heard about an amplifier. What is amplification? First, we'll study what is amplification. Amplification is nothing but when you raise the strength of a weak signal, it's called as an amplification. And the device which does it is called as an amplifier. So amplifier is basically a device which raises the strength of a weak signal. So when the transistor is used as an amplifier, it acts as an amplifier by raising the strength of a weak signal. So in order to operate a transistor as an amplifier, always, as I said, we are going to refer with the common emitter configuration. In this figure, we have taken a common emitter configuration where emitter terminal is made common to input circuit as well as output circuit. This is a signal to be amplified, which is applied between the base and emitter. And the amplified signal we are going to get between collector and emitter. On the collector terminal, we are going to get the amplified signal. And this is a common emitter configuration. We have used two batteries, BBB, which is connected across the base terminal, and one is connected across the collector terminal. So in addition to the signal which you are going to amplify, we have connected the two batteries, BBB in the input circuit and VCC in the output circuit. And these voltages are called as a DC voltages. These are not AC, understand the difference. These are the batteries or a DC voltages. One is connected at the input and one is connected at the output. Why we use that? This is when VBB is used at the input, it always makes the base emitter forward biased, and the VCC keeps the collector base junction reverse bias. So in the second slide, we studied active mode. Active mode means the input circuit should be forward biased and output circuit should be reverse biased. So always, in order to work a transistor as an amplifier, it should be operated in an active region. Means always the base emitter should be forward biased and collector emitter should be reverse biased. So in order to work as an amplifier, we use the voltages. These are the DC voltages, one at the input circuit and one at the output circuit. Now let's study what happens. Whenever we want to, along with this, the signal to be amplified is applied at the base emitter terminal. Okay. So when you apply the signal, okay, already this is a positive terminal is connected to base, that is P type, and negative is connected to N. It is forward bias. When we apply the input signal, this signal during positive half cycle, the base emitter is more forward bias. All of you know that when it is forward bias, the base current increases. Okay, this base current in turn makes the collector current to increase. And so the collector current starts to flow in the output circuit, and always the output is taken across the resistor R. So V is nothing but an IC into RC. So as collector current increases, the voltage drop across RC also increases and we get an amplified output voltage. See, suppose base current increases in microvolt, the collector current increases in milliamperes. This is microamperes increase, it will affect with the milliampere increase. So this in turn gets an amplified output. So if you see the working, what happens during positive half cycle, the forward bias across the emitter junction is increased. Already we have a voltage VBB. Along with that, the positive half cycle, it increases. Therefore, more electrons flow from emitter to collector via the base. Okay, already you know that the base is a lightly doped one. Much of the current is not wasted. Is whatever the emitter emits, the whole is formed as a collector current. This causes an increase in collector current. The increased collector current produces a greater voltage drop across the resistor. And the next comes a negative half cycle. During the negative half cycle of the signal, the forward bias decreases. But even though always the VBB is taken such that it makes emitter base always in a forward bias. So decreases, this results in a decreased output voltage in opposite direction. Hence, we get an amplified output voltage across the load resistor. Okay. So collector current, if you analyze the collector current, so as I said, before applying the signal, the base emitter or input circuit is forward bias, that is because of the voltages VBB, and collector base is reverse bias, that is because of the DC voltage VCC. When you apply the signal, here see, when no signal is applied, the input circuit is forward bias by the battery VBB. So the DC collector current IC flows from the collector circuit, and this is called as a zero signal collector current. When the signal is applied, the forward bias on the emitter junction increases, and depending upon whether the signal is positive or negative, during the positive half cycle, we get the output voltage. And if you see the graph, there are two currents in the graph. One is a zero signal current. This current is because of the DC voltages which we have applied at the base and collector. And one more is the AC signal current IC due to the signal. So total current IC, that is, will be a small current IC. This is because of a collector voltage, and one more current is because of an AC signal applied. So the total collector current is the DC collector current. It's also called as a zero signal collector current and AC signal collector current. Okay, this is how the transistor can be used as an amplifier. So when we use a transistor as an amplifier, it should be operated in an active mode. Base emitter should be forward bias, collector emitter should be reverse bias, and then only the faithful amplification is possible. Next comes an operating point. So this operating point in a session 2, we are going to discuss in detail. So at present, we just know what is a point, operating point. The name itself indicates it's a point which indicates the operation of a transistor. So a point which is obtained from the values of the collector current IC and the collector emitter voltage when no signal is given to the input is known as an operating point. So always, as I said, the most commonly used transistor configuration is common emitter. So when you connect the emitter as common, the input will be base emitter and output will be collector base. Okay. So without applying the signal, when we use a transistor with the DC voltages, some voltages are used at the input circuit as well as output circuit, which makes the emitter base forward bias and collector base reverse bias. So without applying the signal, some collector current flows, that is the IC. Okay. And this is the IC. And without applying the signal, some collector emitter voltage will be there. And this point is called as an operating point. So once again, a point which is obtained from the values of collector current. Here the graph of VCE versus collector current. A point which is, this is a Q point where I am showing you. A point which is obtained from the values of collector current IC and collector emitter voltage VCE without applying the signal is known as operating point or Q point. It's called as a quasi-end point. Means it's a silent. It is called operating point because variation of IC and VCA, that is when you apply a signal, the collector current increase or decrease, that variation takes place about this point, Q point. That's why it's called as an operating point. And the variation of IC and VCA takes above or below this point. So operating point is nothing but an zero signal value is what we say. Zero signal means without applying the signal, what is the collector current flows in a transistor and what is the collector emitter voltage, that is denoted by an operating point. In detail, we are going to discuss how to get an operating point in the next video. So you please go through that. Next comes an biasing. So always when we talk about a transistor, the biasing is the one of the most important topic. So what is biasing? So basically biasing is the process of setting the transistor's DC operating voltage or current condition to the correct level. So DC means without transistor is used as an amplifier. So amplify, when you want to amplify the signal, we have to apply the input signal. So without applying the signal, okay, we do the biasing. So we apply some DC voltages. We are going to apply the DC voltages to the transistor. So how we are going to apply DC voltages? Either we may use a resistors. So the voltage drop across the resistor acts as a DC voltage, or we can use a capacitors, or we can apply a direct DC voltage to the transistor. So using the external components such as resistors, capacitors, and DC voltage, we can set a DC operating voltage to the transistor. So biasing is a process of setting a transistor's DC operating voltage or current condition to the correct level so that the AC signal which you want to amplify is amplified, and transistor always operates in an active region. The first content I said that the transistor, when you want to use it as an amplifier, it should be operated in an active mode. Active mode means the input circuit should be forward bias and output should be reverse bias in all the conditions. So in order to do that, what we do is we apply a small DC voltage to the transistor. So biasing is applying the DC voltage to the transistor so that the transistor works in an active mode. Okay, so if you list why we need a biasing, why actually we need a biasing is, the first point is to ensure proper flow of zero signal collector current. So zero signal means without applying the signal. So transistor is used as an amplifier. When we use it as an amplifier, we apply input signal and the current flows and we get an amplified output at the collector terminal. But before applying the signal, some collector current should flow. This is necessary because the transistor should be operated in an active mode. Active region, when you want to operate it, the base emitter should be forward bias and collector emitter should be reverse bias. So in order to operate the transistor in an active mode, we apply some DC voltages. So when we apply a DC voltages, that is called as a biasing. And when we do the biasing, some proper amount of collector current will flow. That is nothing but a proper flow of zero signal collector current. Then next, maintenance of proper collector emitter voltage. So I said in order to operate a transistor as an amplifier, it should be operated in an active mode. So input circuit should be forward bias, output should be reverse bias all the time. So in order to reverse bias the output circuit, some proper voltage should be maintained at the collector emitter voltage. This is done with the help of a biasing. When we do the biasing, what happens? When we do the biasing, the proper DC voltage we apply it, and because of that, always the collector emitter terminal will be reverse bias. So second reason for biasing is maintenance of proper collector emitter voltage. Okay, so the third one is base emitter is forward bias and collector junction is reverse bias. This makes the transistor in an active mode. And once, as we studied in the previous slide, operating point, that is nothing but an, without applying a signal, what is the amount of a collector current flows and what is the collector emitter voltage, that is nothing but an operating point. So once operating point is fixed, if temperature changes or any parameter changes, it should not change. It should not move. That is not, that is called as a stabilization of an operating point. That is fixing of the operating point. So all these four conditions, in order to meet the condition, that is without applying a signal, some collector current should flow and the transistor should be always operated in an active mode. That is emitter base junction should be forward bias, collector base junction should be reverse bias, and always the collector emitter proper voltage should be maintained so that always it is reverse bias condition, and the operating point should not change with change in the transistor parameters. So in order to satisfy these, we have to do the biasing. So basically, biasing is the process of applying a DC voltages to the transistor so that it operates, always operates in an active mode. Active mode means the input circuit should be forward bias and output circuit should be reverse bias. So how the biasing is done, what are the different methods of biasing, how to locate the operating point, we are going to study in the next session. This completes the topic. So what we covered is a transistor can be used as a switch when it operates as a switch. Okay, so here comes the first question. When transistor is operated as a switch, it works in following regions. So there are 4 regions are there. Already I have explained 3 regions of operation: active, saturation, and cutoff. Active mode, current flows always. Cutoff, no current flows. And saturation, maximum collector current flows. So when we want the transistor to operate as a switch, either it should operate in active or cutoff, cutoff and saturation, active and saturation, and none of them. I think you can answer this. I have repeatedly said that cutoff means off, no current flows. Saturation means on, the maximum collector current flows. So when you want to operate a switch, a transistor as a switch, it should be on or off. So it is operated in cutoff and saturation region. So next comes the second question. To operate transistor as an amplifier, a transistor base emitter junction must be forward bias with reverse bias. So always I repeatedly explained you, the base emitter should be forward bias. When we operate a transistor as an amplifier, it should be operated in an active mode. Active mode means the input is forward bias, output is reverse bias. When we talk about amplifier, C is the most common used one. So in C, base emitter is input circuit, it is forward bias. Then base emitter is forward bias means the next one is collector base. So the reverse bias applied to collector and base. So the answer is B. Third one, operating point. As I said, represents. The A is values of IC and VCE when signal is applied. Okay. Second one is the magnitude of the signal. Third one is zero signal values of IC and VCE. None of them. So I explained amplifier means it should be operated in active mode. In active mode, base emitter is forward bias, collector emitter is reverse bias. Before applying the signal, we do the biasing and we apply the DC voltages. And when we apply the DC voltages, that is called as a zero signal values. So operating point represents zero signal values of IC and VC. Transistor biasing represents what condition? So what is biasing? First we go with the answer. Transistor biasing represent dash condition. A is AC, DC, both AC and DC, none of the above. So already I said before applying the signal, we apply biasing is nothing but an applying the DC voltages to the transistor. So naturally the transistor biasing represents DC conditions. The last one, in a transistor, the collector current is controlled by collector voltage, base current, collector resistance, all of the above. So I think you can guess it very easily. I have told that transistor is a current control device. If the base current increases, the collector current increases. Base current decreases, the collector current decreases. So in transistor, the collector current is controlled by B, base current. Thank you for listening patiently. And you can go through the PPTs once again if you want anything. Thank you for the support.